All right. We're gonna go to implicit derivative. Implicit derivative is okay. First of all, let's go over some mathematicians' name. You guys should know two mathematicians. One is a Isaac Newton, which is an inventor of calculus. But besides Isaac Newton, there's another person. His name is Gottfried Leibniz. Gottfried Leibniz is it also has a huge contribution about calculus. They are the founding father of calculus. They just approach in different notations and they think about different things, but they both solve the tangent line problem, which is the derivative. And they both have the contributed idea of integration. A lot of people says Isaac Newton is actually copy a lot of work from Leibniz, or vice versa. So, but Isaac Newton get most of the credit. Okay, so throughout the lifetime of this classroom, I'm also gonna tell you some few mathematicians' name. This is very important. Isaac Newton and Gottfried Leibniz. I don't know how to spell Leibniz. He's German. So two people. Now there's also Euler. Euler is the one that start with the Euler's number. He's also a very, very important person. There is Lagrange, Ming Bowie theorem. We're going to talk about it. Michael Rolls is going to be all those mathematicians. But I will mention as much mathematician as possible. There's also a very, very important throughout the history to knowing what this contribution is. In your Algebra 2 class, there was a fundamental theorem of algebra is invented by another person named Friedrich Gauss. Those of you guys taking physics with electromagnetism, E&M, you should know Gauss. There's a Gauss law, but he's also founding father of a fundamental theorem of algebra. Okay, so there was a lot of relationship between physics and math. And Isaac Newton is trying to find physics problem actually. He's not a mathematician. He's more a physicist in that time, right? So back then they called it Renaissance man is people who can do all kinds of things. So those are the things. So we're going to talk about implicit derivative. What is implicit derivative? And what kind of derivative we've been doing? So we have done explicit derivative. So we have done explicit derivative. So that's like y equal to x squared. We just take d to the dx on both sides, and I got dy dx. And since we always have y isolated, all the function that we ever did is always y equal to. So this is just going to be 2x. We know how to take a derivative of this. But more idea, that's more like explicit because we have y equal to something. Now, not all the time we have y equal to something, right? We can have different situations. So we're going to think about what kind of situation we ought to do. So let's start by understanding what kind of situation that you are doing implicit derivative. So the first, let's think about xy is equal to 1. How do I take a derivative of this? What? Divided by x, yes. And that's approach is called explicit because I isolate the y first and I take a derivative. And if I take a derivative, then that's going to be -1 over x2. And that's done. Voila, this is called explicit. Now, what if I don't want to solve for y? What if I just want to do x times y equal to 1, and I just want to take a derivative like this moment? Is it possible for me to take a derivative at this moment? So that becomes very, very important because not all function is able to solve for y. I'm gonna give you an example. Um, situation like 5y squared minus y is equal to 7x. Is this possible to solve for y? Why not? Can I isolate y in any way? This is still a function. Oh, actually, I don't know if this is a function because I think it'll fail vertical line test. But it's still an equation. But can I take a derivative of this? I can divide by 7. It's not going to do you any good. Just you can get x by itself. You're not getting y by itself. The whole goal is to take derivative explicitly, is to get y by itself. So when a function like this, when an equation like this, you're no longer able to take a derivative because you cannot isolate the y. If you cannot isolate the y, there's got to be another method to overcome this. So, not possible to isolate y. Therefore, explicit derivative does not work. Does that make sense? Why it does not work? Because I cannot get y by itself. There's a lot of situation like this. So for example, x squared y minus y squared equal to 10, something like this. Not possible to isolate the y. This case I can. This is a very easy case. I can isolate the y. So let's talk about a simple derivative first. The action of taking the command of taking derivative is take d to the dx. So d to the dx of basically x squared is going to be what? 2x. But it turns out there was a 2x here. Now, if I think of in terms of chain rule, is once I take it down to 2, I have 2x. I'm going to take it down to the x as well, right? This is something that you normally don't write it down, but there is a dx over dx. You're going to take a derivative of the x respect to x. But since dx over dx, that's what? Just 1. But so we normally don't write that, just write down 2x. So this, it comes matter here now. Dx over dx. Well, what is dx over dx? We never write that because you're taking derivative of the x. Like imagine there's a 2 bubbles, right? The first bubble is take it down to 2, x, and now I gotta take a derivative of x respect to x. Take a derivative respect x respect of x, that's just gonna be 1. Fairly easy. Is that okay? Now what changed? If I take a derivative of this, then it's going to be what? Yes. No. We're taking derivative with respect to x. Same thing in the last case, but slightly change. dx over dx, we don't write it out. How do I take a derivative of y to the cube? 3y squared, good. But it's not done yet. I'm gonna have to take a derivative of y. Okay, Josh, pay attention. This case, I have to take the chain rule because this is a two layer, right? The first layer is y to the cube, right? Second layer is y. Then I got dy dx. Instead of dx over dx, this is dy over dx, which is dy dx is the slope. Is equal to the f prime of x. Is the slope that we're looking for. Before we don't write down dx over dx, but now we have to because the chain rule require us to. Does that make sense or no? So every time you have y, you're going to resolve with dy dx. Every time just an x alone, so you take a 6x squared, it's going to be 12x. Did that happen dx over dx? Yeah, but we don't write it down. But if it's 6y squared, that's going to be 12y dy dx. Should I write down? Derivative of 6x squared, that's equal to 12x. Dx over dx, we don't write it down. D to the dx of 6y squared, that's going to be 12y dy dx. Does that make sense? Anytime you have y, then you're going to get dy dx. Got it? Okay. Let's take a derivative of this. I want you to take a derivative of this. Combination of both. Gosh, you need some Red Bull. What time do you usually sleep? That's fine. How do I take a derivative of 6x cubed y to the 4th? You have to recognize the two things. One is a 6, it's always there. You can put all the way in the front. You can do 6 parentheses and take a derivative of x cubed y to the 4th. What kind of rule is involving? What? What'd you say, Grace? Product. Yeah, there's a product rule. Did you do a product rule? You did? Did you take, did you do y with different, did you treat y different than how you treat x? Okay. So the first thing I would do is I take the 6 outside, I put a parenthesis. Why is 6 outside parenthesis? Because that 6 doesn't matter there. And then I'll just do x cubed y to the 4th. How do I do product rule here? X cubed y to the 4th. I take a derivative of x first. So it'll be 3x squared. Is that okay? Y to the 4th. Is that okay? Plus x to the cube times what? Dy dx. Nobody said dy dx. Dy dx is what we're looking for. And that's it. Dy dx. And I put a parenthesis there because the 6 is going to distribute to both of them. So it's going to be 18x squared y to the 4th plus 24x to the 3 y to the 3 dy dx. And voila, I take a derivative of the expression. Not equation, but an expression. Now we're going to do it to the equation. What we're looking for, yes.
I'm just a little confused. What is like dy over dx? Like what like that number like you can put in if you have like. So you said it's like the slope.
It's dy dx. It's just, so a lot of people don't understand what a dy dx is. D stands for delta. X over delta y. So it's changing of x over changing of y. So that is the f prime of x or the slope of a function. But then because this is an expression, so it probably doesn't mean anything to you. You're just gonna get a slope, but you can't really solve for it. But when you get to other situation, you can, because when you get the equation that I can do. So I'm gonna do this one here. I'm gonna show you how to do it. So x squared, oh sorry, not x squared, is y to the cube plus y squared minus 5y minus x 5x squared. Oh sorry, that's not 5x squared. I can't read. Minus x squared is equal to -4. Now I have this equation. Is it possible to get y by itself? No. So what we're going to do is we're going to take a derivative with respect to x. Now later on we're going to take derivative with respect to time. But right now we're going to take a derivative with respect to x. I don't know if you have friends in Dr. Phillips right now. High school? Anybody have friends in Dr. Phillips High School? Taking calculus? Oh, they're doing the related rate. And related rate is taking derivative with respect to time. If you even beat my BC class, we already did that. One of the most scariest part of calculus is related rate. But right now we're just taking derivative with respect to x. It's not a huge problem. Can you tell me how do I take a derivative of the y to the cube? There you go. And I'm going to color code this for you, dy dx. What's derivative of the y squared? Plus 2y and the dy dx. I color code this for you, just so you know. What's the next one? Minus 5, what? Dy dx. Minus what? 2x. That's it. Is equal to what? No, you dumb. I was waiting for that too. Derivative of number is 0. Always 0. Now, do you see this dy dx here? I can isolate them by moving everything non-dy dx to the other side. So I can add 2x to the other side, so it's 2x. Then I can factor out a dy dx. Remember that pig problem I asked you to begin the year? That when you have ig and ip, I can factor out I. Same thing here. That's why I asked you to do that problem. All the question I have very beginning is set up for right now. And then can I evaluate dy dx? Yep. So I collect all the dy dx term on one side, and I factor out dy dx and divide everything else over. We good? That's it. Except the next question I give it to is going to be more challenging. You know me. Now, can I find out the slope at a certain point? Yeah. But you need an x value and y value. So in this case, you got x value and y value. Now, I'm going to write down one more thing that's very, very important. So numerator of dy dx equal to 0 is called horizontal tangent. Denominator of dy dx, so denominator, the bottom part equal to 0. You can actually solve for that. That can use quadratic formula to solve, but I'm not going to do that. Denominator of dy dx equal to 0. Denominator of dy dx, which is 3y squared plus 2y minus 5 equal to 0. That is your vertical tangent. Joshua, are you falling asleep? You can bring a Red Bull here. Just put in my refrigerator. I'll just hand you one. I'm not distributing drugs, people. So kids can wake up. All right. So I'm gonna ask you to solve for this one. So x squared minus 6x squared y plus 5y squared is equal to 10. I want you to find dy dx. The only term that you have to be careful is that middle term. I think that's a risky one. I want you to try it first. I want you to see if you can do it right. But I would take out a -6 and put a parenthesis for take a derivative of x squared y. That's something I would do, but I don't know. You do whatever. This is one question on the test right here. You did it? You had to isolate dy dx by itself. Do you do that? But it's okay. You can stop there because I don't want you to continue to do something wrong. So I'm gonna do the first step. What's the derivative of x squared? -6, right? I'm gonna put a parenthesis. Get a habit of doing that. Because that's -6 and distribute both of them. So I'm gonna take a derivative of the x squared y. So it'll be 2xy. Is that okay? Is that okay so far? Plus x squared dy dx. Did you do that? Plus 5. Nope, that's not 5. I lie. 10 y dy dx is equal to 0. Now I'm going to distribute. And I'm going to highlight this too. Sorry. I'm going to highlight those two here. I'm going to change to blue. And this is the one I'm going to isolate. So that means everything else on the other side. So it's going to be -6x squared dy dx plus 10y dy dx. And everything on the other side, so it's going to be -2x plus 12xy. Is that okay? I'm going to factor out dy dx. -6x squared plus 10y is equal to -2x plus 12xy. Then I'm going to set dy dx is equal to -2x plus 12xy -6x squared plus 10y. Now, if I have a coordinate in original function, right? If I have a coordinate original function, then I will plug in the both x and y to find out the slope. So let's just say if I have x equal to 1, y equal to 0, for whatever reason. I don't think it's right. But I can plug in x equal to 1 and y equal to 0. I can find slope at that particular point. Or you want to find a new horizontal tangent, it's going to be numerator equal to 0. If you want to find a vertical tangent, it's going to be denominator equal to 0. Those are the things that you got to be able to do. Any question of this one? Do you understand or you need more practice? Yeah.
In the first step, how'd you get the x squared dy dx?
If I take a derivative of y, I'm going to get dy dx. X squared, I leave it alone. So it's like a product rule.
Oh, wait.
I'm doing product rule of x squared y.
Within that.
And I put a -6 auto in front and put a parenthesis. That's a good habit of mine. That I always make sure that I get it right. Does that make sense? So I'll just give you one more, just make sure you guys understand this. This is the first test question that you're gonna have. So let's say 4x squared minus 8x y to the fourth plus y to the third minus is equal to -6 plus y. Something like this. I want you to take a derivative, finding dy dx. And that could be one question on FRQ as well. So it could be 2 points there. The chance of that showing up now is a lot less than before, because now AP exam has got a lot weaker. So check with each other, see what they get. Check out what you get. not sure, but I only care about calculus. Kevin's hungry though. Friday. No, Friday has a pretty normal schedule, as normal as it can be. It's about 45 minutes to 47 minutes.
I didn't solve it like this, but I didn't think about it. What if you back it out?
You can do it. You can solve a y here. There's no way for you to solve a y because you got y to the q, you got y to the third, and you got y to the other side. Yeah, but why would you want to do that? I don't think it's gonna give you a benefit doing that. Did you guys got it or no? Check each other, see what I get. Good? Check each other.
Yeah, I got to that part, but I'm not isolated. I had dy over dx. It was minus 6 squared. Yeah, it's minus 6 plus y. So when I
I moved y. That was one side. I personally very first time I did it, I didn't know why.
That's what I got. I can do it the other way. If it's completely backwards, then that's good. Then that means you have same answer. You can get negative 8x plus 8y cubed. You can have negative 32xy cubed plus 3y squared minus 1. And that's... Yeah. I distribute this negative 8.
what happened to y on cube?
Huh?
8y cubed.
So there's a parenthesis right here, right? There's a product rule, right? So I'm gonna take a derivative of xy to the fourth. So if I take a derivative of xy to the fourth, I'm gonna take a derivative of x first. So it's 1. Oh, this is y to the fourth?
Yeah,
Oh yeah, my bad. This is the fourth. I just... My fault. I'm kind of hallucinating. This one is a y to the fourth.
He put the y.
Yeah, I subtracted the y. Yeah, no. Yeah.
Oh, well, this is just but the y is
No, but it's that makes it have the function like that. Then I have all my dy dx plus I.
They could have both dy.
All right. Does everybody understand this? I just make mistake on the. For some weird reason, my mind kind of split. When I copy down the y to the fourth, I copy down y to the third, but it's actually y to the fourth. So if I distribute, that's gonna be -8 y to the fourth, and that's gonna be like that. So that's dy dx. Now I'm gonna do one that's a little bit different. Is which one I want? Tangent of x plus y is equal to y squared. So be careful here. Right, be careful here. Why is it be careful here? Because you gotta understand the arguments. You never touch inside the argument. A lot of people have tendency to say, "Oh yeah, that's tangent of x plus tangent of y." That's not correct. The argument can never touch. So what we're gonna do is going to take a derivative of this, right? What's derivative of this? What's derivative of left hand side? Anybody want to give it a try? That's it?
Is equal to 2y d plus dx.
There's a chain rule. It's a function within the function. Does that make sense? So you got 1 plus dy dx. Does that make sense? Equal to 2y dy dx. Are we okay here? There's a chain rule. So yes, implicit can have a chain rule. Now this can distribute here. The whole thing is going to distribute. So it's going to be secant square of x plus y plus dy dx times secant square of x plus y equal to 2y dy dx. Is that okay? Now dy dx on two separate terms. I'm going to move this term to the other side. So it'll be secant square of x plus y is equal to 2y dy dx minus dy dx secant square of x plus y. Usually I do it in one step, but I'm going to take out dy dx here. Of 2y minus secant square of x plus y. And that's equal to secant square of x plus y. And then you can solve dy dx. So that's going to be secant square of x plus y over 2y minus secant square of x plus y. Do not try to be cute. And you know what people do on the test? They do some kill the kitten stuff. Like say, oh, I have secant square of x plus y. I'm gonna cancel out the one top and bottom. No, don't do that. If you do that, you went from a right answer to the wrong answer. You just keep it that way and you're done. You do not simplify x over 1 plus x. Cancel out like this. No, no. I just see that all the time. Like you did so good, and the other way at the end, you cancel out, you break math, and I had to take out the whole thing off. I would have given you 2 check mark if you don't break math. If you break math, I give you 0 check mark. It didn't matter how hard the work is. And I'm gonna tell you right now, don't do stupid things. Every time you cancel has to be a factor. That's the second question on the test. something similar to this.
Wait, in the second part, how did you get secant squared x plus dy over dx?
Because that distributes secant square x plus y into the parenthesis of 1 plus dy dx.
Oh, completely understand. Oh, I see.
How much time until the end of period? I don't know, they have some funky schedule. Piss me off.
24 right now.
All the stupid tests make people dumber. Where's some time?
Yeah, we got
Okay. All right, so does that make sense or no? No?
I'm so confused about distributing square x plus y.
Wait, is everyone who doesn't have a blog today gonna have to watch the video for this, or are you gonna teach it tomorrow?
I'll teach it tomorrow, but if you don't want to stay ahead, they can watch it.
So tomorrow for us, we'll just be doing something else.
We just review all the stuff.
Oh,
I think everybody's reviewed tomorrow.
Yeah.
Shevin, okay? Never touch anything inside argument. It's just a bad idea when you do that. That's automatic wrong. If you touch the argument. Okay, so I'll give you one that's just very similar to like this. I mean, this one's a little bit harder, but that's okay. So chain rule is also applied to implicit derivative. Like I said, calculus is not calculus. Algebra, manipulation, algebra. I have taught a kid is besides Long Long's 4th grade, but I have to teach a kid 7th grade how to do calculus. But Long is genius. Long's 4th grade to do calculus.
he's in 4th grade in calculus.
He asked me a question I don't even know how to answer.
It's like, what is he gonna do like after calculus? Like, is there like a level to how you can go?
Huh?
Is he like what's he gonna do in like high school? Like,
It's gonna be like PhD
stuff?
if he had the right resource. There's a lot of PhD at 12-year-old.
The way he said that's the casual.
No, you look up YouTube. Look up 12-year-old PhD. There's a lot. There's probably like 20 in the United States.
He started planning when he was like in elementary school to get like this level.
Yeah, like for example, Terrence Tall is like greatest math professor in UCLA, and he was at 8 years old. He can do like calculus at 8 years old. He just bored, and his mom had a homeschool. So this kid basically he's homeschooled too. He's not. If he go to traditional school, they were just learning how to add 2-digit number. So he quit school 6 times already. He was so bored. He was like, I'm not gonna stand people that only teach me how to add 2-digit number or multiply 2-digit number. No, he come to my high school competition last year, and he's teaching BC kids how to do like some algebra manipulation, how to complete a square.
Like, did you teach him from like when like starting out? Like, did they come to you afterwards?
I didn't teach him. He's just way smarter. He's smarter than me. Like that. This age. He doesn't need people to teach him. He just need to. People give him the work and he do it. Like he knew what is 2 to the 18th power is. Just
It's got the top of his head.
I think I got it.
all right. Everybody done or no? So watch out for the implicit derivative because of the chain rule. So I'm gonna write down the chain rule here. That's the first bubble and the second bubble here. What's derivative sign? X plus y squared. I didn't touch anything inside. That's gonna be 1 plus 2y dy dx, right? 3. I'm gonna take a derivative of x squared, so it'll be 2xy plus x squared dy dx. Uh-huh. 6xy plus 3x squared dy dx. Cosine of x plus y squared of 1 plus 2y dy dx. Is that okay so far? I'm going to take this whole term and I'm distributing it inside. So it'll be cosine of x plus y squared plus 2y dy dx of cosine of x plus y squared is equal to 6xy plus 3x squared dy dx. So all the dy dx I'm going to move into the left side. This I'm going to move to the left side. So it'll be cosine of x plus y squared minus 6xy. And I'm going to factor out the dy dx on the left side. So it'll be 3x squared minus 2y cosine of x plus y squared. I'm going to divide it over. Three x squared minus 2y cosine of x plus y squared. So that is my final answer. I don't know if I make a mistake. You got it? There's chain rule. Make sure you got this. You can be every term's opposite, it's fine. So you can have 6xy minus cosine of x plus y squared
Okay. Over
2y cosine of x plus y squared minus 3x squared. Because you factor out a negative sign from the top and negative sign from the bottom.
wait, is it minus 3x squared on the bottom there?
Yeah, minus 3x squared plus 2y cosine of x plus y squared. Because you can factor out a negative sign top and bottom, and they will cancel out to become positive. So some people says they got 6xy, right? Minus cosine of x plus y squared. That's the same answer as this one. So it'll be 2y cosine of x plus y squared minus 3x squared equal to dy dx.
No.
They are the same answer.
You what? I have one example. This is somehow possible. That makes sense. Base 3x squared plus 3x.
So this is just algebra manipulation. This is not something crazy. Now I'm gonna go to the last one, which is how do I take a second derivative of something? Now this one's gonna be the hardest one. So I'm gonna take a circle, x squared plus y squared equal to 16. By the way, this is a circle equation. Circle equation is very common. X squared plus y squared. Also on a side note, that y squared, you can solve for that to be 16 minus x squared. This is just some math, sorry. This is some math that this is also a circle. But if the plus square root of 16 minus x squared is the top part of the circle. So 16 minus x squared, that's the top part of the circle, which is top part with the radius of 4. And there's a minus, that's going to be 16 minus x squared of bottom part of the circle. That is going to be the top part and bottom part. So sometimes you can get this equation. This just means a semicircle. They can be the top part or bottom part. So this is on the side. This is, you don't need to know today because this is not something that we're going to be using today. I'm just going to write that question. X squared plus y squared equal to 16. I say, hey, can you find d2y dx2? That means the second derivative. The second derivative is kind of challenging because you have to rely on your original equation and you have to rely on your first derivative. So everybody can take the first derivative. I'm gonna let you take the first derivative. Everybody should be able to get this. Very easy. Nobody should get it wrong. Oops. Is that all, Bill? Okay, I'm gonna finish this up tomorrow.
I said don't quote me.
I'm gonna talk about this.
Dude, I haven't watched it tonight.
I'm gonna finish out this video and you guys can watch it, but
It's been like all over. Yeah. How the world was like. Dude, I had a question. You said
Maybe
if
I'll
you
have
take the derivative twice.
it's okay.
If you take the derivative twice, would it be negative?
No, you have to, once you get to here, that this one is going to be like this. So I'm going to take a derivative again, respect to x. That's going to be d2y dx2. And that's going to be low d high, high d low. So low d high minus high d low over low low.
Oh, I remember the question. I was sneezed. Number 5, part A from the homework.
Yeah.
It was f prime of -1 times g1, and then plus g1 -1 times f g prime -1 times f1, but then
Is that the one with graph one?
Yeah. But I got negative 2 over 3 times 1 plus 2 times 2. But G prime should be 1 over 2, so I don't know why I'm getting 2.
The answer for A, I don't remember. What was it?
It was.
It's okay. We'll look at it tomorrow. And what I'm gonna do is I'm gonna replace this dy dx with the blue one. And that's equal to
Today I actually did the homework. I did what was expected, no way.
and that is gonna be negative y minus x squared over y squared. So I multiply by y over y. So that's equal to negative y squared minus x squared over y to the cube. I can take it out. And let's look at original equation has x squared plus y squared all the way here. And that's equal to negative 16 over y to the third. d2y dx2 is equal to